Have you ever wondered about the origins of our vast universe? A question that sparks curiosity and beckons the intellect. A question that has been asked by countless generations, from ancient philosophers gazing at the night sky to modern scientists peering into the depths of space with powerful telescopes. The universe, a word that encapsulates all that is known and unknown, seen and unseen, understood and yet to be discovered. It's a concept so vast, so intricate, that it can be overwhelming to contemplate. It's an enigma, a grand cosmic puzzle waiting to be solved. As we delve into the mysteries of the universe, we find ourselves embarking on a journey filled with wonder and discovery, a journey that takes us back to the very beginnings of time and space. We'll explore theories and ideas, some established, some still being investigated. We'll encounter phenomena so bizarre and fascinating, they stretch the boundaries of our imagination. We'll traverse the cosmic timeline, from the birth of the universe in a fiery explosion of energy to the formation of galaxies, stars, and planets. We'll venture into the dawn of life, the evolution of species, and the rise of civilizations. And we'll look ahead to the future, to what may lie in store for our universe. We'll explore the enormity of the universe, not just in terms of its physical size, but also in its complexity. It's not just a collection of celestial bodies moving in space. It's a cosmic tapestry woven with the threads of matter and energy, time and space, laws and constants. It's a grand cosmic symphony, with each element playing its part in the harmony of the whole. So are you ready for this journey? Are you ready to delve into the mysteries of the cosmos, to explore the known and venture into the unknown? Are you ready to go back to the very beginnings to understand how it all started and perhaps where it's all heading? Join us as we unravel the mysteries of the cosmos, starting from the very beginning. Our journey begins with a bang, the Big Bang. It's a phrase you've probably heard before, but what does it really mean? The Big Bang theory is the leading explanation about how the universe began. It suggests that around 13.8 billion years ago, our universe was in a hot, dense state, almost unimaginable by today's standards. Picture this. Everything that now makes up the cosmos was initially compressed into a space smaller than a single atom. Yes, you heard it right. All the galaxies, stars, planets, and even space and time itself were once packed into an infinitesimally small point. So what triggered this explosion? Well, that's one of the biggest mysteries in science. But what we do know is that something caused this tiny, dense point to expand rapidly. And when we say rapidly, we mean it. In a fraction of a second, it inflated like a balloon in an event now known as cosmic inflation. This expansion created what we know as the universe, a continually expanding space filled with galaxies, stars, and planets. It's a concept that's difficult to grasp, but it's the best explanation we have for how our universe began. But let's rewind a bit. What was there before the Big Bang? Well, that's another tough question. Some scientists suggest that there was simply nothing, while others propose that our universe might be just one in a series of endless cycles of expansion and contraction. Regardless of what was there before, the Big Bang marked a significant turning point. From this hot, dense state, the universe began to cool and expand, leading to the formation of atoms, molecules, stars, galaxies, and eventually life as we know it. The Big Bang, a simple term for an event of unimaginable scale, marked the birth of our universe. From the chaos of the Big Bang, stars and galaxies took shape. Imagine a universe filled with a hot, dense soup of primordial matter, a swirling, seething mass of particles and energy. As the universe expanded and cooled, this matter began to coalesce under the force of gravity, setting the stage for the birth of the first stars. These early stars were unlike anything we see today. They were enormous, often hundreds of times larger than our sun, and incredibly hot. Their immense size and heat were a result of the abundant supply of hydrogen and helium, the basic building blocks of the universe. The heart of a star is a battleground. Here, under extreme temperatures and pressures, hydrogen atoms are forced together in a process known as nuclear fusion. This fusion releases an incredible amount of energy, causing the star to shine brightly. It's this energy that counteracts the force of gravity, preventing the star from collapsing under its own weight. But what about galaxies? How did these sprawling cosmic cities come to be? In the grand cosmic ballet, gravity once again takes the lead. As stars formed, their gravitational pull attracted other stars, forming clusters. Over time, these clusters merged to form larger and larger structures, eventually giving birth to galaxies. These galaxies, filled with billions upon billions of stars, are the backbone of the universe. They're the cosmic neighborhoods where stars live and die, where planets form around those stars, and perhaps where life takes root. And so, from a hot, dense state, the universe went through a breathtaking transformation. Stars ignited, galaxies formed, and the cosmos began to resemble the universe we see today. It was in these stellar nurseries, amidst the chaos and violence of the early universe, that the first galaxies took shape, illuminating the universe with their brilliance. These stellar nurseries gave birth to the first galaxies, illuminating the universe with their brilliance. And that's how, from the primordial soup, emerged the beautifully structured universe we know today, a testament to the power and elegance of nature's laws. Stars are the heart of galaxies, but around them orbit the fascinating worlds we call planets. These celestial bodies, including our very own Earth, did not just appear out of nowhere. They are the product of a captivating process that unfolded over billions of years. To understand the formation of planets and solar systems, we must first appreciate the role of stars. A star is born when a dense cloud of dust and gas collapses under its own gravity, sparking a nuclear reaction that lights up the cosmos. Around this newborn star, a flat disk of remaining dust and gas begins to swirl. This is the birthplace of planets, the protoplanetary disk. Within this disk, particles of dust and gas start to collide and stick together, forming larger clumps. These clumps grow over time, gathering more and more material. When these protoplanets become large enough, their gravity begins to shape them into spheres, and they clear their orbit of any remaining debris. Voila, a planet is born. In our own backyard, about 4.5 billion years ago, a similar process took place. The sun, our star, came into existence, and around it, the planets of our solar system began to form. One of these was Earth, a rocky planet situated just the right distance from the sun, in the so-called Goldilocks zone, where conditions are just right for liquid water and possibly life. But the process doesn't stop there. Even today, new planets are being born in distant corners of the universe, around stars far, far away. And who knows, some of these might even host life as we know it, or as we can't even imagine. Thus, from the swirling dust and gas around stars, planets and solar systems came into being. A cosmic dance of gravity and matter, playing out over billions of years, has led to the diverse and fascinating universe we explore today. On at least one of these planets, something remarkable happened. Life emerged. Now let's fast forward a little to around 4.5 billion years ago, when our Earth was a young, volatile world. The conditions were harsh, with frequent volcanic eruptions, lightning storms, and a thick, noxious atmosphere. Yet somehow in this extreme environment, life found a way. The first life forms were simple, single-celled organisms, much like today's bacteria. They thrived in the Earth's oceans, protected from the harsh conditions of the surface. Over time, these tiny organisms evolved, becoming more complex and diverse. They developed ways to harness the energy of the sun through a process called photosynthesis, oxygenating our atmosphere and setting the stage for the next major leap in evolution, the emergence of multicellular organisms. Around 600 million years ago, these multicellular organisms started to diversify rapidly in an event known as the Cambrian explosion. This period saw the emergence of the first complex animals, including early versions of many groups we recognize today, like worms, sponges, and even the first primitive fish. Over the following hundreds of millions of years, life continued to evolve, adapting to the ever-changing conditions on Earth. Fish gave way to amphibians, which then evolved into reptiles. Reptiles, in turn, gave rise to birds and mammals. And then, around 6 million years ago, in the vast plains of Africa, a group of apes began to walk upright. These early hominids were our ancestors. Over time, they evolved, their brains grew larger, and they developed tools, language, and culture. Eventually, they gave rise to us, Homo sapiens, the wise man. From single-celled organisms in the primordial oceans to the diverse array of complex life forms we see today, the story of life on Earth is a testament to the power of evolution, Through countless trials and tribulations, life has adapted, survived, and thrived. Life, in its myriad forms, is perhaps the universe's most astonishing creation. We've journeyed from the past to the present. But what does the future hold for our universe? A question that has captivated minds and sparked theories that range from the fascinating to the downright terrifying. Let's dive into some of these theories about the future of our universe. The first is the Big Freeze. This theory suggests that as the universe continues to expand, it will eventually become too spread out to sustain star formation. The existing stars will burn out, leaving behind only their remnants. The universe will become a cold, dark place dominated by black holes. It's a chilling thought, isn't it? Next up is the Big Crunch. This is essentially the reverse of the Big Bang. It proposes that the universe's expansion might one day slow down and then reverse. Gravity could pull everything back into a single point, causing a big crunch. This could potentially lead to another Big Bang, starting the whole process over again, a cosmic cycle of birth, death, and rebirth. Lastly, there's the Big Rip. This theory suggests that the universe's expansion isn't just continuing, it's accelerating. If this acceleration continues unabated, it could become so powerful that it rips apart everything in the universe, from galaxies and stars down to atoms themselves. These theories may seem unsettling, but they're based on our current understanding of the universe. And that understanding is always evolving. With every new discovery, every new observation, we gain a clearer picture of the cosmos and its future. It's worth noting that these events, if they occur, are billions upon billions of years in the future. So for now, our immediate cosmic neighborhood is safe. But the question remains, what is the ultimate fate of the universe? Will it freeze, crunch, or rip? Only time will tell. While the future remains uncertain, the exploration and understanding of our universe continue. It's a journey that we all are a part of, a journey that's far from over. So let's keep exploring. Let's keep asking questions, because in the quest to understand the universe, we may just find out more about ourselves. We've traveled through time, from the birth of the universe to its potential futures. We've delved into the enigma that is the universe, a realm of infinite wonders and mysteries. We began our journey with the Big Bang, the colossal explosion that marked the start of time and space, setting the stage for everything that exists today. We then journeyed through the birth of stars and galaxies, the celestial bodies that light up the night sky. We explored the formation of planets and solar systems, including our own, a process that took billions of years. We discussed the evolution of life, a testament to the universe's ability to nurture complexity and diversity. Finally, we looked ahead at the future of the universe, a topic that continues to puzzle and fascinate scientists. The universe, with its infinite wonders, continues to inspire and intrigue us, reminding us that we are but a small part of a grand cosmic story. Before we wrap up this cosmic journey, we want to hear from you. What part of this journey fascinated you the most? Was it the cataclysmic birth of the universe with the Big Bang? Or was it the birth of stars and galaxies that left you in awe? Perhaps it was the formation of planets and solar systems that sparked your interest? Or did the evolution of life and the future of the universe leave you pondering? Our universe is vast, filled with mysteries waiting to be discovered. Your curiosity and thirst for knowledge can lead you to uncharted territories and unexplored realms. So we invite you to continue this journey, not just as passive viewers, but as active explorers of this grand cosmic story. If this video has ignited a spark of curiosity in you, if you've learned something new, then please give a like to this video. Share your thoughts, your opinions, your questions in the comments section below. Let's create a community of cosmic explorers, journeying together through the infinite wonders of the universe. Don't forget to subscribe to our channel for more such content. Share this video with your friends and families. Invite them to join us on this journey, because the universe is a story best shared with others. Remember, every like, every share, every subscription, every comment brings us one step closer to unraveling the mysteries of the universe. So join us as we continue our exploration, our quest for understanding, our journey through the cosmos.